guys, Digital Principal and Computer Organization. The subject code is CS3351. This is Unit 1 Combinational Logic and Part 8. In this video, I am going to explain you about what is meant by multiplexer and demultiplexer. Let me move on to class. So what is meant by multiplexer? It is a kind of combinational circuit which has 2 to the n 2 to the power of n input and it will going to provide only single output. So it has more number of input and going to provide the single output with the help of this n number of input. As usual, usually in digital electronics, the binary information is received from input line. So the input is given as either 0 or 1 and it is directed to the output line. On the basis of the value of the selection line, one of the input will be connected to the output. So here we will use the selection line because if the output is connected to the one of the data input. If you have only one output, right? So this output is connected to any one of the input and it will be used as the selection input. So here we have n selection line. It means if you have 4 input means you can use either one of the input as selection line. The multiplexer is also treated as mux. There are various types of multiplexer. Here I will mention a few and important multiplexer. First one is 2 by 1 multiplexer, 4 by 1 multiplexer and 8 to 1 multiplexer. In 2 by 1 multiplexer you will have 2 input and 1 output. In 4 by 1 multiplexer you will have 4 input and 1 output. In 8 by the same procedure that 8 input and it is going to provide only 1 output. The first one is 2 by 1 multiplexer. So 2 input will be mentioned with A0 and A1 and the single output is mentioned with the Y variable. So the selection line, we will take this any one of the input as the selection line that is going to connected with the output. This is the block diagram of 2 by 1 multiplexer. You can use enable pin and selection pin. The output is 1 and the input is mentioned with A1, A0. This is the truth table for 2 by 1 multiplexer. Input is considered to be selection and the output is considered to be Y. When A0 is equal to, when selection is given as 0, your input is connected with the input A0 is connected with the output. When the selection pin is given as 1, your input pin A1 is connected with the output. Okay. For example, here I am going to give 0 as selection pin means 0 as the value means your A0, this is A0 and this is output and the remaining one more input is A1. So this output pin is going to connected with this A0 value. If you give 1 as output and the output pin is going to connected with A1. The logical expression of Y is equal to S dash dot A0. So A0 value is 0. S dash when the 0 is given a selection pin, so that's why you will mention as S not dash. And when it is connected with A1 input, so the selection pin will be 1. So it is mentioned with plus S naught dot A1. Draw the logical circuit for this logical expression, that is y equal to A naught S bar plus A1 S. So mention here two input, one is A naught and another one is A1. And A naught is S is connected with the AND gate, that is product, that's why you need to use AND gate. And A1 and S is going to here also you need to connect one more AND gate, and this both will be constructed by using the OR gate. The final output will be constructed by using OR gate. This will be considered as an selection input. Either it will be 0 when it is connected with A0, and it will be 1 when it is connected, the output is connected with A1. 4 by 1 multiplexer. In 4 by 1 multiplexer, you will have 4 input values and 1 output value. In 2 by 1 multiplexer, you will have 1 selection line, but here you will have 2 selection line, that is S0 and S1. So S0 and S1 is one of these 4 input are connected to the output. This is the selection pin S1 and S0, and this 4 will be the input, and you will get one output, that is Y. This is the truth table for input and output. When S1, you will have 2 selection, that's why if you have 2 way input, you need to fill 0 0 1 1 and next input as 0 1 0 1. If you give 2 selection line as 0, your output will be A0. Your output line is going to connected with A0. And if you give 0 1 0 as selection 1 input and S0 as 1 input, your output is going to connected with A1. 1 0 A2. 1 1, if the both the selection line will be given as one value, the output is going to connected with the A3 input. So based on this equation, you will derive the logical expression y equal to, first write it down this value, that is A0 dot S, S0 dash and S1 dash, because when the A0 is connected with the output, your both the selection value will be 0, that's why you will mention with S1 dash and S0 dash plus S1 dash and S0 A1. In here S1 is 0, that's why you will mention here as S1 dash, and S0 is 1, you will mention S0 as 1 and A1 into A1 plus the same procedure will be followed to A2 and A3. Finally, this is the equation for logical expression of 4 by 1 multiplexer. With the help of this logical expression, you will design a logical circuit. This is the logical circuit of 4 by 1 multiplexer. Two selection one line, one is S1 and S0. Afterwards, all these gates are connected with the OR gate, that is Y, final output. The final one is 8 by 1 multiplexer. 8 by 1 multiplexer. Here you will have 8 input and 1 output value, and the 8 input value is mentioned from A0 to A7, and here you will have 3 selection line and a single output. The selection line is mentioned with S0, S1 and S2. S0, S1 and S2. Mm. So one of this selection input, one of the selection line will be connected to the any one of the input. This is the logical diagram of 8 by 1 multiplexer. This is enable pin in A0, A1, A2 up to A7. You will have input and 3 selection line. One is S0, S1 and S2. This is S1 and this will be X2. And this is final output, that is Y. How will you fill the truth table with 3 input? The first input is filled with 4041 and the next input is filled with 0011 and the third input is filled with 0101. When both the 3 selection line is given as in is given as 0, you need to get the output as A0. You need to connect the output with A0. If you give 001 as the input, your output is connected with the A1 input. If you give 0, 1 and 0, so you need to connect with A2. So if this truth table is easy to fill, the same procedure, just you need to mention the different input variable as S2, S1 and S3, S0 and output as Y and mention the top to bottom as A0 to A7. Then write the logical expression with the help of this truth table. If you have 0, you need to mention this input value with complement. If you have 1, you need to mention this input value as it is. Just I will explain this few. First value is A0 dot S2 dash because S2 is mentioned here 0 and S1 dash because S1 is mentioned here 0 and S0 dash it is also 0 here. Like that you need to write the equation from A0 to A7 for 8 by 1 multiplexer. With this help of this logical expression, you will construct a logical circuit. This is the logical circuit of 8 by 1 multiplexer. Here we will mention with 8 input and 1 output and 3 selection line. If it is mentioned with bar means complement means you need to use NOT gate here. For product you need to use AND gate. For OR operation addition you need to use OR gate. Final output is mentioned with overall OR gate. All the 8 input will be mentioned connected by using the OR gate. Next one is demultiplexer. The demultiplexer is opposite to the multiplexer. Here you will get you are going to give only one input to get 2 power n output line. That is, if you are going to give one input means you will get 2 to the power of 1. That is 2 output. If you are going to provide 3 input, your output will in the demultiplexer will be 2 to the power of 3. That is 8 output. So in simple word, it has single input and more number of output. This is also a kind of combinational circuit. So the information is received from the single input line and directed to the output line on the basis of the value of selection line. The same what are the procedure mentioned in the multiplexer is opposite to the demultiplexer. Usually the demultiplexer is also mentioned with the name as demux. There are various type of demultiplexer. Here I will mention you the important and few multiplexer. 1 by 2 multiplexer, here you will have 1 input and 2 output. Next 1 by 4 demultiplexer, 1 input and 4 output. Next one is 1 by 8 demultiplexer, 1 input and 8 output. 1 by 2 demultiplexer. Sorry, 1 by 2 multiplexer. In 1 by 2 multiplexer, you will have 1 input and 2 output. And the 1 input is mentioned with uh, so 1 by 2 demultiplexer, your 1 input that is mentioned with A and 2 output that is mentioned with Y0 and Y1. This is the block diagram of 1 by 2 demultiplexer. Y0, Y1, and A is given as input, and there will be one selection line that is mentioned is S0. This is 1 by 2 demultiplexer. Next one is 1 by 4 demultiplexer. This is 1 by 4 demultiplexer. Here you will have 1 input and 4 output. So the total number of output will be from Y0 to Y3. Sorry, input will be Y0 to Y, output will be Y0 to Y3, and two selection line that will be S0 and S1, and one input that is A. The input is connected to one of the output. This is the block diagram of 1 by 4 demultiplexer. So usually demultiplexer has one input that is A, and this is 1 by 4 demultiplexer, that's why it has 4 output from Y0 to Y3, and it has two selection line, one is S1 and S0. Truth table for 1 by 4 demultiplexer. So S1 variable is mentioned with 0011 and S0 is mentioned with 0101. Why I will mention the output as for first A and next one is here A. We will have the output based on this selection line. The output line is connected to the input line, and the input line is there will be only one input. That's why I will mention here as A. Okay. In most of the book or in some other notes, here there will be a mention of 1. Both will be right. Okay. So this equation will be based on this truth table. Why not? When both the values will be 0, both the selection line will be 0 means your input is going to connect with first output value, that is Y0. When the selection line is given as 0 and 1, your input is going to connect with Y1. The same procedure is applicable to both these two input value. And write down the logical expression based on this truth table, that is Y0 equal to S1 dash S0 dash, because here both the value will be given as 0 into A. Like that you need to write the equation for Y1, Y2 and Y3. In Y3 the two values will be given as 1. That's why it is mentioned with the as the name variable itself, that is S1, S0 and to A. Next one is 1 by 8 demultiplexer. In 1 by 8 demultiplexer, there are total of 8 output, that is Y0 to Y7 and 3 selection line S0, S1 and S2 and single input, that is A. This is the block diagram of 1 by 8 demultiplexer. This is the output of 1 by 8 demultiplexer. The output is given from Y0 to Y7 and 3 selection line S0, S1, S2 and truth table. Here 3 variable, as I told you before, 3 variable means you are going to have 8 values. The first input is given with 8081 and the second input is given with 0011 and the final input is given with 0101. You will mention the output from Y0 to Y7, not to Y7. When the 3 selection line will be 0, your output is connected with the, your Y0 output is connected with the A input. Like that, you need to fill the truth table in the diagonal position as A or either with 1. Both will be the right. And your equation is also based on the truth table. Y0 is filled with A into and all the selection value will be 0. That's why it is mentioned with S0 dash, S1 dash and S2 dash. For Y3, the selection line S0, S1 is given as, for Y3, S0 and S1 is given as 1 and S2 is 0. That's why here we will mention as S2 dash. The same procedure is applicable for from Y0 to Y7 to write the logical expression. And this multiplexer and demultiplexer is one of the important topic which are going to ask you in the university examination. This is the logical diagram based on this truth table. So you will have 8 output and 1 input, this is input, and 3 selection value. Based on this expression, you will draw this logical circuit. So Y0 is equal to S0 dash, S1 dash, S2 dash into A. Like that, you with the help of this equation, you need to connect this input with the concerned output and you will get AND gate because it all mentioned in the dot. Dot means product. For product in logical circuit we will use AND gate. This is the logical circuit for 1 by 8 demultiplexer. So thank you guys.